Hello everyone. In this video, we are going to study the Bayes theorem and its application. So Bayes theorem can be used especially in medical tests, but in this video it is mentioned to detect the patient is having the cancer positive report or negative report. So let us study the definition of Bayes theorem. So according to the Bayes theorem, in the probability theory and statistics, Bayes theorem, also known as Bayes law or Bayes rule, describe the probability of an event based on condition that might be related to event. Suppose P of A given B is equal to P of B given A, P of A divided by P of B, where P of A by B is equal to posterior probability. When to apply Bayes theorem? Part of the challenge in applying Bayes theorem involves recognizing the types of problems that warrant its use. You should consider Bayes theorem when the following condition exists. Within the sample space, there exists an event B for which P of B greater than 0. The analytic goal is to compute the conditional probability of the form P of A given B. You know at least one of two sets of probability described by the given below. P of A intersection B for each belongs to A. P of A and P of B given A for each given A. Here, according to the Bayes theorem, these are the some rules must be exist when we going to solve some complicated problems. So first one is sample space of the event. Let us consider B is an event, that B is must be greater than 0. Then only we have to apply the Bayes theorem. The analytical goal is to compare the conditional probability of the form. So you must compute in the form of conditional probability such that P of A given B. This is also one of the important rule to apply the Bayes theorem. The last one is at least one of the two sets of probability described below. So it is also one of the application. So now let us see, does patient have cancer or not? The available data in the form of particular laboratory test with two possible outcomes, positive and negative. So in the laboratory of cancer test, so there will be a two possible of getting chances, either positive or negative. The test returns a positive result in only 90% of the cases in which the disease is actually present, and correct negative result in only 97% of the cases in which the disease is not present. Furthermore, 0.008 of the entire population have cancer. P of having cancer is equal to 0.008. P of not having cancer is equal to 0.92. P of having positive report with cancer is equal to 0.98. P of negative report with having cancer is equal to 0.002. P of having positive report not given cancer is equal to 0.03. P of having negative report having cancer is equal to 0.97. So in this due to the pollution and all, there were furthermore 0.008 the entire population have the cancer. By this data given, we must compute whether a person is having cancer or not. P of and some the available data is from, and it is from particular laboratory test with two possible outcomes. There are many people who have given the test. They must be some of the people may be positive and some of the people may be negative. In this is the best example to determine the cancer testing by using the Bayes theorem. The test returns correct positive result in only 98% of the cases. It will detect only positive in the 98% of the cases. Actually, it is the disease is present, and correct negative result is only the 97% of the cases in which disease is not present. So, does patient have cancer or not? Suppose we observe new patient for whom the lab test returns a negative result. Should we diagnose the patient having cancer or not? If when the person given the test, if he get the report negative, P of H given D is equal to P of D given H, P of H divided by P of D. P of cancer having negative report is equal to P of cancer having negative report into P of cancer. That comes to be 0.0016. P of cancer having cancer given negative report is equal to P of having cancer negative report into P of cancer. That comes to be 0.96224. This is the, as I told, when to apply the conditional probability. This is the perfect example for conditional probability. So which one is more, we have to going to consider the for. So 0.96224 is more. So P of cancer having negative report, that is more. So this is the person is having the cancer, 0.962224 percentage, that person is having the cancer. And this P of H given D is equal to P D of given H. It means that posterior probability is equal to exterior probability. So P of H given D, it is always opposite to we already know that P of cancer having negative report, as I show in previous slide, it is 0.02 into P of having cancer in total population is 0.008. So when it is multiplied, 0.00016. And next, P of having cancer given negative report, P of having cancer negative is into P of having cancer. It is 0.97 into 0.9992 is equal to 0.96224. This is the best way of detecting the cancer. Does patient having a cancer or not? According to the analysis, should we diagnose the patient as having cancer or not? P of H given D is equal to P of D given H in P of H divided by P of D. We know that it is from Bayes theorem. P of cancer having negative is equal to P of having negative report having cancer into P of cancer, 0.00016. And while doing the both the problems, which quantity have the more numerical, we are going to consider. P of not having cancer given negative report is equal to P of not having cancer into P of cancer is equal to 0.97 into 0.992. It comes to be 0.962224. So here 0.00016 and 0.9622224, which one is greater? 0.9622224 is greater. So P of not having cancer given negative report is major here. So according to our problem, the person who has given the test comes to the report that not having the cancer. So this is one of the medical tests, like cancer is one of the major diseases we are facing in our day-to-day lives. By this it can be helpful. Thank you.